Have you ever opened a class and seen 13 if-else statements and thought, who the heck wrote this code? Or maybe you added just one more condition and suddenly your clean method turned into a decision jungle. Today, I'm going to show you how experienced developers avoid that mess without magic, without over-engineering, using something called the strategy pattern. And by the end of this video, you'll know exactly when to use strategy, how to remove messy conditionals, and how to make your code open for extension but closed for modification, like a pro. This video is part of my series Design Patterns Code Like a Senior Dev, where we take patterns that sound intimidating and make them practical. And trust me, today's example is painfully relatable. Imagine you are building a payment system. Your boss says we need credit card payments. You implement if payment method equals credit card, process the credit card. And next week he says add PayPal. So what do? You put an else if statement and then check if payment method is PayPal, then process the PayPal payment. And then Stripe, crypto, buy now, pay later, and suddenly your class looks like an if-else jungle. Now, here's the real problem. Every time a new payment method comes in, you modify the existing code, which means there is a higher risk of breaking things. Pull requests are gonna be bigger. There would be more merge conflicts, and there would be one very tired developer, you. So here's the main question. What if we could add new payment methods without touching existing payment codes? That's exactly what strategy pattern gives us. The strategy pattern is about encapsulating algorithms into interchangeable objects. Let me translate that from textbook English to developer English. Instead of writing one class with many conditional behaviors, we write one interface, multiple concrete implementations, and inject the behavior during runtime. In simple words, don't ask what type you are. Just execute your strategy. Each payment method becomes its own class. Each class knows how to process itself. There's no if-else, no switch, no drama. The strategy pattern has three main players. Number one, strategy interface. Number two, concrete strategies. And number three, context. In our case, it would be payment strategy, then there would be credit card payment, PayPal payment as concrete implementations, and then a payment processor, our context. Now let's build it step by step. All right, let's refactor our messy code. So to start with, I'll comment out this code, and then I'll start with the payment strategy interface. Now, this interface defines one contract. If you are a payment strategy, you must know how to process a payment. It declares a method that takes in decimal amount and it processes it. So after that, we need to create some concrete strategies. In the code that we wrote before, we had a credit card and a PayPal strategy. So we'll just expand on that. So now we'll create public class credit card payment, and it extends payment strategy. So now because it extends payment strategy, it needs to implement the method process payment. In order to save time, I'll just paste it. Process payment takes amount, and then let's assume this is the logic that actually goes to the payment gateway and processes a credit card payment of a particular amount. For PayPal, we'll do exactly the same thing, just the difference is that this would do PayPal payment rather than a credit card payment. So more or less it appears to be the same. It also extends from payment strategy and has its own implementation of process payment. Did you notice something beautiful here? There is no if condition, there is no switch condition. Each class owns its own behavior. So we talked about interface, we talked about concrete implementations, and we talked about the third thing, which is context. We need to create a processor class that would process the payments irrespective of what type of payment it is. All right, so I'll implement that class quickly. Let's call it payment processor. It would store a read-only payment strategy in it. All right, I'll quickly create a constructor that would take an payment strategy. Let's call it payment processor rather than pay processor. All right. So it takes in payment strategy, and then it assigns it to the read-only private variable. After that, this class needs to know how to process payment. So what it would do is process, and then it takes a decimal amount. Right. So now, depending upon what payment strategy we choose, we need to process payment using that strategy. Right. So this becomes the context class, and this class doesn't really care about what payment type it's using. It just says, hey strategy, let's do your thing. And that's the part, that's the abstraction. So once everything is done, let's implement the old messy code into strategy pattern. So I'll declare a variable strategy equals new credit card payment. So we have defined our strategy now. Now I'll quickly create a processor object that is new payment processor. Now payment processor takes in the strategy. So the strategy that we are passing right now is credit card payment. And once that all is done, we process the payment for, let's say, $20. So let's run it. All right, so it process the credit card payment of $20. All right. Now I want to see a payment that is done through PayPal strategy. So let me quickly create a PayPal strategy. If only I can spell it right. New PayPal payment, and then I'll just create a new processor, or I can just reassign the old processor equals new payment processor, and in that I'll put the PayPal strategy. Once that's done, let's process another payment, this time for $150. Let me again run this. All right, so credit card payment of 20 was processed, and another PayPal payment of 150 was processed. So it's working as we expected. Here's what just happened. Before, adding new payment method forces you to modify an existing class. And after implementing the strategy pattern, adding new payment method is as simple as creating a new class. We followed open-close principle that is part of Solid, which we'll cover in another episode. So use strategy pattern when you have multiple ways to perform the same action, you see too many conditionals, you want runtime flexibility, and you want to follow open-close principle. You need to avoid it when you have just one behavior or you are over-engineering for future possibilities. So today we learned why if-else explosion is dangerous, what strategy pattern actually means in plain English, how to implement it cleanly in C#, and when to use it like a senior dev. And now you can add new behavior to your systems without touching existing working code. That's powerful. This video is part of my series Design Patterns Code Like a Senior Dev. If you want to stop writing beginner level code, understand patterns deeply, and think like someone with years of experience. Patterns don't make you senior, knowing when to use them does. See you in the next one. Till then, take care.